Allumage de EAP, décollage.
The BepiColombo mission to Mercury is off to a successful start. Within hours of launching from the European spaceport in French Guiana, the spacecraft had unfurled its antennas and two 15-metre solar arrays. Monitoring cameras even took some selfies, showing one of the solar panels and two antennas. A few days later, the spacecraft deployed a 3-metre boom containing sensors to record magnetic fields, and a monitoring camera captured this 1-minute manoeuvre in a series of images. The sensors have already returned their first data, but there's a 7-year journey ahead before the main science begins, and there's a lot to learn. These images from the NASA Messenger mission are the best we have of Mercury. It has highlands and lowlands like other planets, but unlike Earth, Mercury rotates on an axis perpendicular to its orbit.
Due to the fact that Mercury is not tilted, there are some craters on the poles where the sun never shines into it. And inside these craters, Messenger found water ice. It was detected even earlier in the 80s from ground that there were rather bright spots, and there were some hints that it might be water ice. But now from Messenger, we are pretty sure that we have water ice in craters. And that's pretty much surprising. Think about it. You have a planet on the surface 450 degrees, and then you have water ice at the poles. It's kind of unbelievable.
Fortunately, there's an instrument on board called metre, which can measure the surface temperature directly to see if it's cold enough for water ice. Knowing the makeup of the planet's dark surface is also important. A team at DLR, the German space agency, have built a special chamber to heat up samples to examine how they behave at high temperatures. These can then be compared with what will be found on the planet. Planetary scientists are unsure how it formed. It could have originated beyond Mars, with an impact pushing it closer to the Sun. Or it could have formed at lower temperatures in its current position. If so, current theoretical models will need a rethink.
And one of the things why I like working on Mercury is we need to understand Mercury in order to understand how planets form. If we have a model that forms all planets but not Mercury, that model is basically useless because you need to get that one as well.
NASA's Messenger mission did a great job, but BepiColombo consists of 2 orbiters using complementary orbits with more combined instruments. Plus, unlike Messenger, it will obtain high-resolution images of the entire planet. The planet is also shrinking in size, possibly due to cooling. Plus, there may be active volcanoes, so there is much more to learn.
Mercury is a very mysterious planet. Every time we went there, we found new surprising results. And that is the reason why we do BepiColombo. And we hope with BepiColombo, on one hand, we are able to answer many of these new questions. But I'm pretty sure we found a lot of new surprising results which raise new and other questions which we then need to follow up.
BepiColombo arrives at the planet in 2025. Then, for this joint mission from ESA and the Japanese space agency JAXA, it will be time to unlock Mercury's mysteries.